All right, so yesterday we talked about being able to read a contour map. And before that, we talked about how to draw the contour maps. Today, after we finish these two words, at the two vocabs that we finished at the bottom, we're going to learn the next step with contour maps. So let's finish this up. Looks like we still had to. Yeah, oh, we got days worth of contour map stuff. All right, so we did everything but islands and highest possible elevation yesterday. So let's knock those two out of here so we can finish up. So guys, what's an island? Something surrounded by a body of water. Now, I guess I should have specifically mentioned what's an island in the ocean?
An island.
It's the body of a piece of land surrounded by water. And hey, what would the elevation be at the beach on an island? 0.
Yep.
Because what does elevation mean? It means height above sea level. So on a beach in the ocean, you are at sea level. When your toes are in the water on the sand at the beach, at an ocean, then you are 0 feet, 0 meters above sea level. So an island on an ocean, I guess, again, I should have mentioned, you can tell if something's an island if the first contour line, like this one, the first contour line is 0 all the way around. So that's all we need to put here for island. If the first contour line is 0 all the way around.
Wow. We should do that.
So if the first contour line is 0 all the way around, it's an island. Is land.
Yep. I'm gonna start calling it Island now.
So with that is pretty simple. As long as you know that an island has 0 all the way around, I have really just wanted to make sure you understood that simple concept. The next one is a little bit trickier. Highest possible elevation. So if we come back to this map, what does this BM mean again? We did that yesterday. It's a benchmark, and it just means right there at the dot, it is 123 meters above sea level. Now, if you remember, I said yesterday that 123 is not anything special. It's not the highest, it's not the coolest, it's not the prettiest. It's probably the easiest is really what it is. There was a parking lot there and they took a measurement. But now what I want to know is what could the highest possible elevation be on this hill? I want everybody to think about this for a second. So let me restate the question again. Here's a hill. It's the tallest area on this map. How do I know it's the tallest spot on the map? Okay, because I look at the numbers. It's 120. It's the biggest number there is. But my question is, what is the highest possible elevation?
123.
No, what did I just say? That 123 is not the highest, not the prettiest, not nothing. 139.
Hey, what is that? Huh?
Huh? I don't know, you were talking, so I looked at you to see what you were saying.
How did you get 139?
How did I get 139? Okay, so let's talk about this. Okay, so just because some people get it faster than others, that does not, as long as you get it by the end, it doesn't matter. So let's talk about this. We know there's a 120 on this map, right?
Yeah.
How do we know there's a 120?
Label.
Because it's labeled. That means right there is a 120 on this map. There's quite a few of them on that whole circle. What would the next line be? How'd you know it was 140? Because they're going up by 20s, remember? So the next line would have been 140. Are there any 140s on this map?
Absolutely.
How are you so confident there's not?
Because there's not another line.
Because there's not another line.
All that,
Did it just click?
yeah.
So there are absolutely no 140s. But there could be 139s. Why could there be 139s? Okay, do we draw lines for 139? No, that's 19 more than the last line. So we don't know if there's any 139s. I don't know. There could be, there might not be. But what I know there's not is any 140s. There are no 140s because they would have drawn the line. But that means there could be anything less than that. And the highest, that's why I worded it this way, highest possible elevation could be one less than what would have been the next line. Let's write that down. In fact, that's pretty much exactly what it is. And then we'll look at it again to make sure it makes sense. So the highest possible elevation is one less than what would have been. So one less than what would have been the next contour line. For example, on this one, the last line was 120. The next line would have been 140. So you just subtract 1 from that. So 139 meters.
Hi, Zach. Welcome to
Hey.
class.
Carter, knock it off. I know you didn't even write the example. You didn't. So again, you just go to what would have been the next line and subtract 1 from that. No, remember this one was given in meters.
My turn.
So the next thing I want to show you is, well, what the heck is the Regents going to do? And now that I think about it, I probably should have just printed you copies of this. I will for my next 2 classes. Here's an actual old Regents exam. This one's getting kind of old. It's from August of 2011. So you guys were just babies, right? Not quite babies. What, 4 years old? Okay. So this is an actual old Regents exam. And again, always read all the words, but here we have a map. It's actually quite simple compared to some of the ones we've been looking at. They already connected all the lines, so there's no lines for you to draw. You see that they labeled one of the 100s, and we've got some letters. They give us the contour interval. What does the contour interval mean?
20.
What does it mean?
By 20.
Means they go up by 20. So they only labeled the 100, but we know they go up by 20. And then they gave us a map scale. So they are going to ask you a few questions that pretty much all go with the notes we just took. So let's take a look at this. And I'm going to turn off the lights so maybe we can see a little better. The first question they ask is, what is a possible? And I'm actually going to change that from what is a possible to what is the highest elevation at the triangle with a dot on the side of it on top of Patty Hill. It's legit what we just did.
169.
Okay, close, but not quite. Okay, so hang on. Let's walk through it.
Oh.
So they ask, what is the elevation here at this triangle? Do we have, how do we even get started?
You said labeling.
You want to label the lines? Is that what you want to do?
Yeah, 120, 140, 160.
Okay, so how do we know that this line is going to be, so they do go up by 20s, but how do we know that this way is going up
Is this north?
and not, no, up and north are not the same thing.
What's going up?
How, that's my question.
Okay.
How do we, because the lines are getting smaller. You guys know as you go up to the top of a mountain or the tops of the hills, the top of the hill is smaller than the bottom of the hill, meaning like how wide around it is. So this is going to be the base of the hill. In fact, it's even way out here is the base and it goes up, up, up and gets smaller as it goes up. So this is going to be the top of the hill. So that's how I know it's getting higher going this way, just like Carter said. So we've got 100, 120, 140, 160, and that's all the lines there are.
Oh, the triangle should be like 165.
No, hang on.
No, Carter.
How do we figure out the highest possible elevation? We just took the notes on it.
You do the second line.
We do what second?
170.
Wait, is the next,
180. If it was
oh, what's the next line? If I was going to have another line, what would the next line
79,
be?
180.
180, not 170. Because remember why?
Going up by 20.
Going up by 20s. So the next line would be 180. Are there any 180s on here?
Oh, it should be 179.
So you just subtract 1 from that. So you had 180 and you subtract 179. By the way, make sure you read all the words. These are feet
Feet.
this time. So you would have had to label that feet.
Good job, Dwayne.
The next one, same thing. We did these notes yesterday. Indicate using a compass direction. So again, they spelled it out. Don't say up, down, left, or right. They want a compass direction for the steepest side of Patty Hill. So there's Patty Hill. We want, which side is the steepest? If you forgot how to figure out steepest, look at your notes from yesterday. So we forgot how to do steepest. What did you find there, Zach, for steepest? How do we do steepest?
Section.
Yep. What do your notes say for the steepest section?
They're close together.
Where the contour lines are close together is the steepest. So we take a look at this map. We've got Patty Hill here. Which side of Patty Hill is steepest? Okay, we got a north answer. How do we figure this out? Okay, so first of all, we use the compass.
The peak.
Okay, this side, anything, this side of Patty Hill is going to be the north side of Patty Hill. This will be the south side.
So it's gonna be
This will be the east side of Patty Hill. This is the west side of Patty Hill.
so above the line is north.
Yeah, so this side of Patty Hill is gonna be the north side of Patty Hill. I just cut Patty Hill in half. That's all I did. So
The peak right
is it the north? Now, do we care about the peak?
is-
No, the peak is not what we're looking for. We want the steepest, which Zach, how did you say the steepest? We figured out
lines are close.
where the lines are close together. So that's right here. What side of the hill is this?
North.
Is it the north? Because
Or east.
this is also north,
It's like northeast.
like northeast. You do have to include that. So the lines are closest together on the northeast side of Patty Hill. You could spell it out or do the N and the E for northeast. Explain how the shape of the contour lines crossing Blue Creek show the direction that the creek is flowing. So this is what we talked about yesterday. Here's Blue Creek. Flip back in your notes to figure out how we look at the contour lines. So notice it didn't say which way is Blue Creek flowing. It says, how do the lines, what about the lines tell us which way it's flowing? Destiny, what did you find in your notes about which way the creek is flowing? Or the river, what do we call it? Direction of stream flow. What did it? First of all, it goes downhill. The second bullet though is what we're more concerned with. So, because this question specifically said how the shape of the contour lines. So in this case, they know you know that water always flows downhill. They want you to relate that to the shape of the lines. Guys, everybody take a look at the shape of the lines here. Here's Blue Creek. What happens to the lines when they touch Blue Creek? Guys, do you see what's happening to the lines every time they touch Blue Creek? They bend. Here's a bend. See how they all bent? You don't see that?
No, I do.
Okay, we don't need those types of comments then.
No.
So they all bend there. And our notes said that they bend upstream. Do you guys know what upstream means? Is that where it's going or where it came from? Where it came from. Upstream means uphill, so where it came from. Or another way of thinking about it is water flows out of the bend. So notice, here's the bend. So water's going down into Taylor Pond. But does that answer the question? Explain how the shape of the contour lines crossing Blue Creek show the direction the creek is flowing. How do they want us to answer that? We got to talk about the bends to the direction the stream is flowing. And so they bend, which way do they bend? Upstream. Or a better way of saying this is water flows out of the bend. Okay, we'll practice lots of that. This next question says a student placed a floating wooden block in Blue Creek at location A. 15 minutes later, the floating block arrived at location B. What is the creek's rate of flow from A to B? Express your answer to the nearest 10th. Believe it or not, last chapter, you learned how to do that. Math, last chapter. Math and earth science are best buds. Hey, when we did math in earth science, did you have to memorize it?
Yes.
No. Grab your reference table and find the page that has math stuff on it. You don't have to take it out if you have it in your binder, just open to that page. What'd you say, Carter? It is on the front page. What formula, now that you guys have that math page in front of you, would help us figure out the rate of flow of the river? Rate of change. We're not going to do this today. I'm going to pull this aside for Monday and we're going to do it then because we are running out of time. No.
You got me excited.
Zach, you're a fun kid.
You got me excited.
I'm sorry. We really haven't even started.
Fire.
This last question is the one I want to focus in on now. On the grid in your answer booklet, construct a profile of the land along line CD. Plot the elevation of each contour line that crosses line CD and connect the plots with the line to complete the profile. Guess what we're learning today? Thank you for participating. We're going to learn how to draw a profile of the land. So better step back and say, what the heck is a profile?
I know what profile is.
Oh, a side view of an area. It's like somebody might have turned the page and looked at that, which is always fair game, guys. Crazy. A profile is the side view of an area's landscape. A model uses an upward and, you know what? Let's just circle that. A profile is a side view of an area's landscape. It's kind of like an outline of the land. Let me kind of show you. So here we had this map before. So I've shown this map a couple of times. So there's the contour map. We're now going to take this contour map and learn how to draw the side view. So you can see where it goes up, where it's flat, where it goes up, how it comes down, how fast it comes down. We're going to be drawing basically the outline of a mountain. And there's steps for that. And they're actually clear, concise steps that if you follow these steps every single time you do one, you will draw yourselves beautifully drawn side views of the mountain every time you do it. So there are technically 6 steps. Are you ready for them?
No.
Never mind. Here they come. I don't know why I put things in question format for you. Step one. And we're writing these in the boxes on the bottom of page 30. So you see the box that's labeled number 1. You will determine the contour interval and write it in for each line. So we're going to write these steps first. Then I'm going to demonstrate them on the board, and then we're going to all do one together. So step 1 is to determine the contour interval and write it in for each line. Okay, step back. What is a contour interval?
Number.
The numbers. It's what the lines count by. So like I said yesterday, they're not always going to be labeled.
40.
Right. So in this case, I labeled a 20, I labeled a 60. I think most of you really quickly can say that goes 20, 40, 60. Yeah. Yes, but that I don't think would ever happen. Not at least for us. So in this example, again, you guys figured that out. It would be 40 for that one. That's easy. Step 2. And this one, there's a little bit to write. So I do want you to write it word for word. I'll give you time. So I'm going to let you write it while I fill up my water, and then we'll talk about it. This one sounds really weird until you see it, and then it makes perfect sense. That will be our scrap paper. Yep, we're not doing it yet. We'll do it together in a second. No. Good idea. So we're going to take a piece of scrap paper. You put it along the line that you're measuring. So in this case, it's going to be AB. It's very important that you read the directions or the problem that you're doing it for, because sometimes there's going to be several lines on the paper and you need to do it for the one they say. For example, on this one that I had on the board, it said along line CD. So line CD it doesn't even go across the whole map. It just is a little part of the map. So here's what this means. Place the scrap paper along the line to be profiled. So you just take your paper, move it over. You don't have to do this now. We'll do it all together in a second. And then here's the weird part. And mark each place the contour line touches the paper. This is what that means. So I've got my paper along the line. Then you just mark, okay, there's where that 20 line crosses my paper. There's the 40 line, there's the 60. The 60 line touches twice back to the 40. So you just have this piece of paper with little marks on it. The next step, step 3, place your scrap paper on the x-axis. So I know this sounds like we're doing a graph because I added the word x-axis. It's not really a graph. It only kind of looks like a graph. We're really drawing a picture, and we're drawing a picture to scale using some graph-like paper. But why I'm emphasizing this is all those rules for graphing, you know how you have to go up by even numbers, they have to be perfectly spaced. All of those are out the window because this is not a graph, it's a picture. So did everybody get step 3? Place your scrap paper on the x-axis. Okay, step 4, another one where there's some writing. Oh, okay, here's what you do. Sorry. This one has a little bit of writing, and again, it doesn't make much sense until you see, and then it makes perfect sense. You got, well, you can see we're stopping with notes at step 6, so, and step 5 is only 3 words. Take your time, get this one word for word, just like the last. So I don't think this is quite as much fun as the connect the dots, but this is a good second game to do at your next party.
I forgot.
We could color.
Why?
All right. So step 4 says for each line on the scrap paper, make a dot on the graph directly above it at the number of the contour interval. All that means is see the 20 mark you made earlier? Put a dot on the 20 line. See the 40 dot or the 40 mark you made before? Put a dot at the 40. Lots of dots. Step 5, connect the dots.
Connect the dot.
Okay, but step 6 kind of goes with step 5. Nah, there's just a rule for connecting dots when you're in 10th grade. And that rule is hills are not flat. Meaning once you get to those 2 dots that are the same, so in this case, the 2 60s, you don't just connect them straight across. Because remember that whole highest possible elevation stuff? We know the hill goes higher than 160, or I'm sorry, higher than 60, but it doesn't go to 80. So your hill, when you're connecting the dots at the top, you just curve it up higher than the 60, but not up to 80. So step 6 is kind of more like a rule, not a step, I guess. You ready to learn this? Practice it?
No, I'm ready to go home.
Well,
I'm not
okay,
ready to go
again,
home.
why do I ask you guys questions? Ready for this? No, I did it again. Let's do it. That's good.
No, let's go home.
It's not an option. That is not your bell.
It is an option. You can go to this place, fix it.
Okay, so let's practice this. If you notice, the next page is the same exact map if you didn't already notice. And there's a graph-like paper at the end. I actually need you to do something first before we actually practice this, because I kind of screwed up. I did not make my lines long enough, so just for real quick, take your lines on the graph and just take them over to the edge of the paper.
On both sides?
No, it only need, you can do it on both sides, but you only have to do it on one side. So that was my mistake. That is not part of making a profile. You will never, ever have to do that again. I know, I screwed up. I'm not perfect, just better than most.
Wow.
All right, so everybody do that part?
Yeah.
What did step 1 tell us to do? No, wait, so does everybody have scrap paper? Anybody need scrap paper delivery?
Didn't follow directions. Didn't follow the directions. Didn't follow directions.
Okay, so I was thinking of saying that too, but they took over my sarcasm. Everybody got scrap paper now?
Step 1.
So now first of all, I want to just talk about this scrap paper. Guys, there's nothing fancy about my scrap paper. I was just literally trying to save paper. That's why I cut them up. So don't tell me when you have homework on this, which you don't tonight, but don't tell me I didn't have any scrap paper. You can use literally the edge of anything. You can use your math homework. I swear your math teacher won't mind. So you could use your reference table. So you got a few marks on your reference table. Just use any sheet of paper you own. Step 1, what did it say, Zach? You already started talking about it.
Determine the contour.
Determine the contour interval and write it in for each line. Now here's, because I've done this a lot of years, can I give you guys a hint that's not written down? So you guys know step 2, right? What's step 2? Go back and flip over if you can't remember.
With scrap paper across line.
Okay, so since we're doing line AB, we're gonna do this. This is step 2. But going back to step 1, where we have to label the lines, now that you see what step 2 looks like, where should we probably put our labels? Where would be a good place to put the labels, since this is what step 2 is gonna look like? My point is, put the labels above the line so you can see them for step 2 and you don't have to move your paper. So that's not really a rule, but take that as a hint from somebody who's done this for a lot of years. Okay, so that one's 0. Yeah, this one's 100. I'm gonna label it again. So Zach is able to tell they go up by 20s, but if you couldn't tell, pick a number and see if it works. Pick 10, 10, 20, 30, 40, 50. I need higher. So 0, 20, 40, 60, 80, 100. Should I stop labeling there?
No.
Why not?
That's silly.
Because no, there is no 120. But why should I not stop there? I have to go all the way to B. So yes, you're going to label the 100 line again, and the 80 line again, and the 60, 40, 20, 0. So you have labels going across. Now I know you probably can't see my labels, and you don't need to see my labels. You only need to see the labels in front of you. So that's step 1. Step 1 took a few minutes. Step 2, like we already said, says take your scrap paper and put it along the line you're going to profile. Take a second, make sure it's nice and lined up.
Nice lined up.
So my line's going straight across line AB. So it says place your paper along the x-axis or along the line and mark everywhere a contour line touches it. So here's the 0 contour line. Right there is where it touches my scrap paper. I am now going to label that 0. Then the 20 line touches right here. I'm labeling it 20. All the way across. It's not silly. That way we get the whole mountain. And yet they start to repeat themselves. 100 is twice, then 80, then 40, 20, 0. So now I should be able to take my piece of scrap paper and come look at yours, and they should truly be absolutely identical. Same labels, same marks. My scrap paper should look absolutely just like yours.
Got it. Silly business. Okay. Where's my Joe? Where's my contact? Where's my contact? Don't have it in your. Joe.
Check one. Oh, you're just labeling them because you didn't have that right.
Joe.
It was harder. Easier to go. All right, couple helpful hints. Once you make one mark, once that 0 mark was on there, you can't move your scrap paper even a little bit. It stays perfectly lined up with the line, because if you just let it float away a little bit, all your lines are going to be just off by a little bit. You can't make it go up on an angle or move it at all on your paper. So then you just have a scrap paper that looks like this. Everybody's scrap paper look like that? Okay, what was step 3? What does yours look like then?
Yeah, I didn't like the 60 and 80 like that.
Oh, okay, so you wrote 60 and 80, just like normal, like my 20s. Okay, so that's a habit that again, another thing, because I know I've done it. Oh, well, that's a 0, but, okay, anyway, that's again, another thing I do, because I know I've done it long enough. I knew that when I got over here, I can't write that small. So I made a little mark and I went down with my 100. You don't have to do it that way. If you are able to write small enough, do it. Whatever floats your boat. Destiny, I saw, turned her paper and did it that way. That's good too, if the numbers are nice and easy. They're not always going to be easy. As you can see on some of these, they zigzag all over the place. So I don't recommend labeling them after you mark them, and we'll talk more about that next week. But what was step 3? What was step 3?
Place scrap paper on.
So place the scrap paper on the x-axis. Again, it's not really an x-axis, it's just the bottom.
X.
So that's legit step 3. So you just put your paper perfectly straight across the bottom of this area. Now, what was step 4? No, that's step 5. Step 4 says for each mark on your scrap paper, we got to put a dot on the graph where it belongs. So here's what I mean. Again, do not move your scrap paper. Once it's there, it's there. So here's the 0. I'm going to put a dot directly above the 0 on the 0 line.
All right.
Same with 20. So 20 is way over here. I need to put a dot on the 20 line directly above my 20 mark. Now, here's another thing, guys. It's super important that you don't let your dots drift away. Meaning, don't just use your eyeballs. I kind of drag my pen very faintly so I can make sure that I'm getting straight above it. Because if your dots drift away just even a tiny bit, the regents won't give you credit for it. Because they're mean and they want you to be perfect.
Well, not everyone's perfect.
No, but there are ways to make sure you're as close as possible to perfect.
Yeah, come on, win. Go, got it. How did you get doing? Connect the dots.
Okay, so notice again, when I draw them, I kind of leave these faint lines. And that's okay. They're good with you leaving those faint lines. You don't even have to erase them. No. Now remember, step 4, 5 and 6, they go together. Connect the dots, but what do we do at the top of the hill with those two 100?
Make a little arc.
You got to make a little curve. It has to go above 100, but do not touch the 120. Because there is.
Okay.
No, because there's still room on your scrap paper for more. So everybody's tops of their mountains might be a little different than mine. Some might go almost to the 120. Some might just skim above the 100 a little bit. It's okay. It doesn't, some might be like a little steeper on one side and a little more gentle on the other. We don't know what happens above the 100. So whatever you have above the 100 is fine, as long as it doesn't touch the 120. So again, should we throw away the scrap paper? I would like you to try and keep the scrap paper because, no, don't keep it here. Put it in your packet. Use it like a bookmark in your packet. Then put your packet in your folder. If your scrap paper gets lost, it's not the end of the world. But if 25 of my 30 kids bring it back, that's 5 sheets that we didn't have to waste then. Guys, enjoy your weekend.
No problem.
That's it.
I'll only enjoy the weekend if we win the night.
Well, then I guess you better play